I'm with American Electric Power, which we call AEP. And just a preface of who AEP is, we're the largest utility in the United States as far as generation and transmission and river fleet. And we have about 39,000 megawatts of generation. 65% of that generation is coal-based. Hence goes, why do we need carbon capture and storage? We have 22,567 employees. You say, well, how does he know that? Well, you heard I was in charge of food services too. So it's part of the food and facilities. And making 22,657 employees happy about what they eat and where they stay is worse than dealing with all the environmental problems I've ever seen. So as I said about our generation, we're 65% coal-based generation. We emit, which makes us the largest user of coal in the Western Hemisphere. It then makes us the largest emitter of CO2 in the Western Hemisphere. Last year it was about 140 million metric tons. The year before, 150 million metric tons. The economy, not what we've done, I think had more to do with that than the reductions. We have, over the last 5 years, reduced our carbon footprint voluntarily by 50 million metric tons through efficiency of our coal fleet, efficiencies in our power plant, and just doing things better. Through forestry offsets, we have 10 million acres of forest in Bolivia and Brazil that we use as carbon sinks and offsets. We have 6,000 megawatts of gas, so here being in the gas country, I don't feel guilty talking about coal. We're a large user of gas and probably will be larger in the future as we shut down some of our older coal-fired plants. 3,000 megawatts of renewables and 2,200 megawatts of nuclear. So we talk about carbon capture and storage and climate change. Why is it important? Because without all the tools in the kit, we heard yesterday in the CEO panel, I don't know if all of you were there, that we need all the tools in the toolkit. Carbon capture and storage is not panacea. It's not the only thing that's going to get to the CO2 levels that we need by 2050, but it needs to be a part, needs to be one of those arrows in the quiver, along with more gas, more renewables, more energy efficiency. There's no silver bullet. When you cherry pick and take one of them out, whether it be coal or gas or any of the other issues, we can't get to where we need to get to. So we need all the bows in the quiver. Our project at Mountaineer, West Virginia, is the first ever carbon capture of flue gas going to full scale. Currently, we're injecting a slipstream of 20 megawatts, 2 miles below the surface, and storing it differently than the process that Judy talked about. They're both capture, they're both sequestration and reuse of the CO2, but it's a lot different for us in that we're capturing it off the flue gas of our stacks using a chilled ammonia process, which the problem in the generation business has always been you can capture the CO2, but the parasitic load or the energy that it takes to capture that is overwhelming the cost of what it costs to do that. So when we started the project at Mountaineer, it was about a 40% parasitic load. We're down now in the 20% range, which for us is different, again, than the gas and oil industry. We use that energy to provide energy to our customers. It's different than taking the load off of a high-stream gas line and separating it. But they're both extremely important. We hope to prove the technology. We will be taking the Mountaineer project to a 235 megawatt, 90% capture rate by 2015. In reality, we believe that'll be 2014. We just received a grant from the government, which always scares us to be partners with the government in the United States. I don't mean that offensively, well maybe I do, defensively, but trying to get that money from the government is hardly worth the effort in many ways, and that's why I think it's important that we heard yesterday about industries that are moving forward. That's why AEP is moving this technology forward next year. We're bringing in partners from India and China and to share our results at Mountaineer. We are running into some IP problems with Alstom in that letting in other people see the technology and then it ends up back in the United States or other countries under a different name. So that's a big part of the sharing process. But what we have learned is how to do the process better. We went in efficiencies from 40% parasitic load to 20%. That's significant. We believe that we can get that parasitic load down to 15%, which reduces the cost. Currently, the project is about $600 million just to put the carbon capture and storage. We do not see a problem with the storage. We've been storing gas below ground in the gas industry for decades and decades. And the whole purpose of it is that the gas stays there, and then if you have leakage, you're losing money. So the worry about that we're going to have this massive gas leak, or CO2 leak, I think, is unfounded, and we believe we should move on past that. It is a different chemical product, but we're currently injecting 100,000 tons a year, and we are seeing no problems with that. We will, by 2014, 2015, be injecting and storing 1,500,000 tons, and it is part of the solution. And saying that we're going to stop using coal or natural gas or any of the other fuels in this country or in the world, I think, we're fooling ourselves. We get 55% of our energy from coal in the United States now, a big chunk from gas, and we need to balance our portfolio approach, but we need to do it with all the tools that we have, and that includes the carbon capture and storage. So I don't have slides. I just wanted to talk about it, and I think the Q&A will feed us into more discussion about this project versus other projects going on. So thank you.